So have you ever wondered how mice work then? Like, obviously you push it around the desk. Or in this case, you move your thumb on this bit and it kind of does the same thing. But still, how do they work? Well, let's take some to bits and find out, shall we? Not going to take this one apart because I can't work out how to get into it without destroying it. It seems that mice are so cheap now, they're just sort of like a unit and you buy it. Like, I'm fairly sure this is screwed shut, and I bet I'd have to pry these off, but then this will probably never go back together again. Interestingly, if you can read it, it says Class 1 laser product. So there's a laser coming out of this. And that's all these things are, right? This is just a small laser, or at best, infrared diode. And then there's probably a single chip inside this that senses it, processes it, and turns it into a USB signal. If I opened this, there's nothing inside it. There's a chip and some buttons and a connector for the cable. They're boring. These are a bit more interesting. Like, this speaks USB. It also speaks PS2. So let's look inside this. We'll get to this thing in a minute. There, this is a bit more interesting. So it's got a big ball. You'll notice there's a pattern, and it's not a uniform pattern. This also weighs nothing. It's not solid. It's quite lightweight. Unlike this thing, which is pretty much a steel ball bearing coated in rubber. But again, we'll get to that in a minute. So in here, you can see there's some kind of chip that'll do everything. There's the wheel, there's some micro switches, that's where the cable connects, and then there's this weird contraption, which all that is the little window that there's some sort of image sensor behind, and there's a bit of a scratch on that because this rubs against it. These just hold it still. And it shines, in fact you can see it there, there's two infrared transmitters there, and then there'll be a sensor behind this, and I think back when I got this it claimed it used artificial intelligence to see the pattern on the ball and detect its movement, and that's all that is. There's not a lot inside this, it's still quite complicated with this bit. You know, this has to decode what's going on with the ball and turn it into either USB or PS2, depending on what we plug into this. If I plug a PS2 converter into this, so if I plug this in, which is a completely passive thing, this is now a PS2 trackball. This must detect this somehow and then just send out PS2 data instead of USB. So this is still quite intelligent. So let's go for this thing. These are about as simple as we can make a mouse. This one also doesn't work, and there's a reason it's open. So this is the mouse from my Atari ST. This is almost as old as me. Maybe it's 10 years younger at best. I've clearly taken it apart. That's because it's broken and needs fixing. See if I can try and fix it. It has a ball. And it has this. Ignore this bit for now. So this is the circuitry. And you'll notice it looks almost as complicated, you know, there's a chip, there's some bits and pieces, there's two buttons, there's this big plastic thing. It's not too dissimilar to what was in this. Except this is about 1,000 times simpler. This doesn't do USB, doesn't do PS2. It sends pretty much raw data out these cables, and we'll look at that in a minute. But let's look at how this bit works. So I have a ball. The ball goes in the hole. When you push it around on the table, it makes these little wheels move. So you can see as I move this, these little wheels move here and here. They're pushing against the ball and they move these bits. Across here is an infrared transmitter and a little infrared detector, and there's two of them, and the same on here. And the reason for that is because on here, I don't know if you can see it, there's little holes in this wheel. There are tiny little holes that the infrared light shines through. And there's two, so it can detect which way this is moving. Now there's a problem with this one, that it doesn't detect the motion at all. If I plug this in my computer, it doesn't move the pointer on the screen at all. And I was trying to work out why. And I think this chip is broken. So this chip here is an LM339. I've got a spare one. I think this is knackered. I'm going to swap it for this one. And what they are, I'll put this up better on the screen, is a voltage comparator. So all it does, it takes two voltages, compares them, and you get an output based on the comparison between them. Now I'm going to hook this up to my scope in a minute and move these, and you'll see that it doesn't quite work as it should. So I've completely gutted the mouse and connected it up to my power supply. So it's powered on at the moment, a little blue LED. I've connected the buttons up, so they do something. Which also means this one hasn't got the most common failure of an ST mouse, where the buttons stop working, which is quite nice. Means I don't have to try and find one of these weird things. So it should be fixable. These wires here are connected to this chip. I've desoldered the actual mouse cable. That's here. As you can see, it's got one of those connectors and it's just wired straight through to that. So I took that off and I just attach my own wires so I can clip things to it. And the way this seems to work, if I just bring up the picture again. So it seems that two of these are connected to two of these, and then two of these are connected to the other two, and it sort of compares the voltages between some voltage reference and the flashing to produce a square wave. And the two square waves are offset. Depending which way they're offset tells the computer which way that particular wheel is moving. What I'll do is I'll hook this up to the scope and we should be able to see something happen. So I made a little diagram of what was connected to what. So this is how the socket's connected up, and I'll maybe put a nicer version up here if I can find it. And then this is how I've connected up the wires. So this sort of, what colour do I think that is? I've decided that one is brown, and the brown one is what's called X1, so I need the grey one, which is X2. So if I clip onto both of these, what I should see is two square waves as I move one of these wheels. Now you can see that we're not getting anything at all. This is just not working at all. The mouse is powered on, I'm moving these. There's nothing appearing at all on these little traces. So let's start probing the actual connections on the chip. Let's see, there's two inputs, two more. So it's the 8 at the bottom. So let's just probe around here, see what we can find. There, we're getting something there. So you can see as I move the wheel, there is some sort of waveform happening there. Otherwise, there's just like noise happening. Right, so there, if I move it, I get something. And on that, where is it? and there I get something. So I've found the 2 pins on this that the wheel is attached to, well, the 2 little sensors. It's the first one and the third one. Then on the other pins of that, you can see there's a voltage difference. And then the same will happen on this one, I bet. If I do that and spin it, nothing there. There's one. Nothing there. And there's one. But the outputs from this chip, which are on the top ones, aha, there's something. So if I zoom out on this, you can see there's a nice 5-volt square wave based on me rolling this backwards and forwards. Or at least I'm rolling it in one direction and I'm getting a square wave. But I'm not getting another square wave from anywhere else. If I roll this one, there's a square wave. But the way this mouse works, I should be seeing 2 square waves for each wheel. So I think this chip has died because there's nothing else on here that can fail. These infrared LEDs work because I've looked through this camera in the dark and you can see 2 little red glowing things for each one. All these are just passive components that, you know, it's a resistor. And there's a capacitor, but that capacitor is not big or interesting enough to fail after 30 years in a computer mouse. So I think the chip has gone. So what we'll try and do, take the chip off, whoops, swap it for this one and see if it's any different. There we go, that was quite a painless operation, I think. If you look back at some of my earlier videos where I'm soldering, you can see I had great difficulty removing things. Well, that was easy. So I put the new chip in. Let's power this thing up and see what happens. Have I fixed it? Have I made it worse? Well, it's drawing a bit more power than it used to. But that isn't hot, so I think that might be normal. Let's be daring and just clip straight onto these leads and see what happens. So which 2 do I need for one of them? Purple and grey. So you can see now if I move the wheel, we get a trace there. If I put it on another input, we get a trace there, which means I should get, I think that's what that is, 5 volts. Right, so it occurs to me that this might actually be broken. This chip might also not be working properly, because the outputs are always at 5 volts. Doesn't matter what I do to the inputs, they are always at 5 volts. If I clip onto the leads that are connected to them, I'm just getting 5 volts out and nothing happens. What I should be seeing is square waves coming out of this, and I don't. So I wonder if that chip I've just replaced is also dead. It's not shorted out though, because it's not hot and it's not drawing any current. Let's see if any of the inputs and outputs are shorted to it, anything. Yeah. So there's a short between VCC and the output pins. Let's just check my soldering. Well, there we go. I've just replaced a broken chip with another broken chip and spent 15 minutes trying to work out why it doesn't work, when in fact they're shorted together. In fact, quite a lot of this chip is shorted out. I'm surprised it hasn't gone up in smoke. Fantastic. So yeah, I think I've fixed it. I don't really know. Like, the scope trace showed one of these kind of doing what I think it's supposed to do, but that's the thing, I don't quite know what a mouse is supposed to look like on a scope. What I imagined was two square waves offset from each other that moved depending which way the mouse wheel was moving. But I'm just seeing weird things. So either the chip was knackered and I've replaced it, but now there's something else that's not working, or I don't know what. But we'll put it back together and later I'll see if it works for my ST. So yeah, first thing is to get these off and then put these back on. But fortunately, I know what colour it should all be. So I'm going to turn on my highly irritating soldering iron again and leave that to warm up. Don't know why it clicks and ticks. I mean, it was, how much did I pay for this? It was like my first video, 20 quid? Yeah. First ever YouTube video, I paid somewhere talking about this soldering iron. It was 20 quid. I mean, I've got a year out of it so far. It's good enough so far, isn't it? We are using the finest flux for copper pipework, brass and mild steel. Obviously designed for precision electronics. I mean, it works, it's just really sticky. And I'm fairly sure it's a little bit corrosive, going off the rust that's on the tin it's in. I guess one day I might buy some real flux for electronics, but this actually seems to work. Certainly not no clean. can't wipe it off on my trousers because it makes them sticky. He says as he wipes them off on his trousers. Ah. There we go. So, soldered back on its cable, which seems alright, I guess. It's a bit chewed up and manky, but then it is nearly as old as me, and probably about as in good condition. I had to fix a little bodge there. I lifted this pad when I was putting the socket in, so I had to bodge that. I don't think any other pads are damaged. No, right. So yeah, I don't know why this wasn't working the way I wanted it to work. I had in my head I'd be able to show you these working with a nice scope trace, but instead there's like 10 minutes of me just fussing with my scope trying to understand even how this is supposed to do anything. Like, I understand that these roll and you can see through the little holes, and then that sends pulses to this, and this compares it to a known voltage and puts out a square wave. But for some reason when I probe it, I don't see square waves where I think they should come out. Like these top 4 pins are outputs. I see a square wave on one of them, but not on the other 3. And it's really confusing. So, if I've done something obviously wrong, tell me in the comments. But if this is just old and knackered and that's just how they go, then equally, put me out my misery, tell me. But for now, let's just put this back together. So, the ball mouse goes there, the wire goes there, and then we find the screw. There we go. You know, I kind of had fun pulling this to bits and trying to work out why it wasn't working. It certainly kept me occupied for a few hours, and I hope it made interesting watching. I mean, if you're still here now, then clearly it was. So if you've not liked the video and all that kind of YouTube carry on, it'd be nice if you did. You know, there'll be more videos, some a bit more organised than this one, others about as random. Ooh, my balls are dusty. You don't want dusty balls, do you? Whoops. See, that, right, is, you know, it's a steel ball coated in rubber. At school, the IT technicians very quickly realised to superglue these in here, because teenagers discovering a mouse has one of these inside it that comes out. They either all go missing or they start getting thrown around the room at people. And that, bouncing off things, could potentially be quite painful. And hilarious when you're 15. You know, you throw that at your mate's head. That's kind of funny for a 15-year-old. But yeah, do some damage with that. Oh, come on, go in the hole. There we go. There we go. Atari mouse, very dirty one. I'm not tempted to clean it. I don't really care that much. I believe when I got this, I used it, and as soon as I understood that you could get new mice that were better than this, I quickly stopped using this, put it in the box, because it's pretty horrible. I mean, the replacement mice weren't much better, but at least they weren't square with sharp edges. I don't know whose Atari person designed this, but yeah, I think they've been to a few 70s Atari parties when they came up with this idea. Very, very strange design. But there we go. That was fun. Goodbye. I'll see you later. Wait.